Hey guys, Miss Dags here. First of all, sorry I'm not here with you today at school. I was summoned for jury duty, so I'm there trying to see if they want me to be part of their jury. Hopefully, I'll be back to you very soon. Um, but that's what I'm doing today. So, your sub should have given you one of these. It's a little packet that we're going to kind of work through, some today and some tomorrow. This particular day is all about the law of superposition. Now, we have had stations for the last few days, and this law of superposition is something that happened and or came up in almost every station. It was on the web quest a lot. It was part of the relative dating page. It was in your notes. Um, anyway, a lot of the stations, it was part of your vocabulary. It was part of the timeline station. That's when we did Who Left Last. And so we're going to kind of look at some of that today and see. Sorry if you hear my chair squeaking, but we're going to see if we can kind of make sense of all this. So I'm actually going to start with this station called Who Left Last. I just got up so I could get a copy of that. If you want to kind of follow along with me in your notebook, you can turn to the green section if you'd like to. The green station, but this is the one that was called Who Left Last, and this is sort of the station I intended to introduce this topic to you with. And so the one that said Who Left Last started with this scenario. Someone forgot to turn off the light at the school, and it says the last person to leave is the culprit. And so you know who or what, how everyone gets to school. And so you can kind of go through this. Principal drives a car, coach walks, security guard has a guard dog, science teacher rides a bike, band director rides a motorcycle. Then you were asked to look at the order of events. So what happened first, what happened second, what happened third. So a lot of you did a pretty good job with this, and you were able to tell me pretty successfully that you thought the coach left first because they walk, and you can see that they're kind of underneath almost everything else. So you said the coach left first. After the coach would be whoever was on the bicycle. That is the beautiful and talented science teacher. Then right after that is the motorcycle. The green line represented the motorcycle. So the band director rides the motorcycle, so they would have left third. After that, we would have only two left. We have the tire marks left and the footsteps with the dog. Since the footsteps with the dog are on top of the tire tracks, then I know that the principal left fourth. And then finally, the security guard left. So if we're going from order of oldest events to youngest events, the oldest were the ones on the bottom and the youngest were the ones on top. And that just kind of makes logical sense for us, and how we know that tire tracks or footprints or whatever are left in mud. And so then it came down to this, and it said, how does this method of logical thinking relate to the geologic history of Earth? And some of you really struggled with this station, and especially these two parts. And so I'm not really sure why or how, but I just want to make sure that we get it all cleared up. And so it says, write this. The law of superposition states that in any sequence of rock or sediment layers, the youngest sediments or rocks are at the top of the sequence and the oldest are at the bottom. So when we're talking about the law of superposition, we're pretty much exclusively talking about sedimentary rocks. We're talking about sedimentary rocks because they're the ones that get deposited in layers. Most other rocks don't generally get deposited into layers. Some igneous rocks can, if like a volcano erupts or something like that. You can also have intrusive and extrusive rocks, which we'll talk about in just a few minutes. But generally, sediment gets deposited in layers. One sediment, like maybe river rock, is deposited. Then other things kind of settle on top of that. And then there'll be more things that are deposited and more things that settle in on top of that. And eventually we end up with these layers of rock. The layers of rock are called rock strata. Rock strata is just a fancy way to say rock. And so we're going to kind of translate this idea that the oldest things are on the top. I just said that all wrong. The oldest things are at the bottom and the youngest things are on top. Now, if you're thinking about sedimentary rocks, like maybe picture the Grand Canyon. The Grand Canyon has visible rock strata. You can see the layers, the horizontal lines throughout the rock that makes up the Grand Canyon. Would it make sense for Mother Nature to pick up like this giant, huge section of rock, maybe covering the whole state of Colorado, shove in a new sediment layer, and then put everything back down? Of course not. That doesn't make real life sense. What actually happens is that the surface is exposed to weathering and erosion, so the top can kind of be weathered down, or things can be deposited on it and build up. And so, when presented with rock layers, you should understand that the oldest is at the bottom, and as you move towards the top, it gets younger and younger. So, we're going to start with this first one. If you haven't already found this worksheet, this should be the very first picture you see. Okay, now that you found this worksheet, we're going to kind of walk through it a little bit. I've already told you that the oldest layers are at the bottom and the youngest layers are at the top. I don't know why I had to change my voice with that, but whatever. The oldest layers are at the bottom, the youngest layers are at the top. So if you work from bottom to top, then you can kind of order the letters. So I'm going to just kind of cover up all this right now, and we're just going to kind of talk through this. I'm going to cover up all the extras. Now, in these, I can start at the bottom and say, well, they must go P, K, M, S, B, J, F. That must be the order of rocks as they were deposited. And that is totally, totally true, except when you look at the rest of this picture, there are some weird things that we sort of need to talk about. Rocks are laid down in layers that go horizontally, but sometimes there are things that can come through and disrupt those. We can have a fault line that breaks. We can have magma kind of come up and melt everything in its path. We can have weathering and erosion that takes place at the surface. Any of these things that kind of cause the rock strata to be ununiform or unpredictable, we call unconformities. And there's a few different versions of that, like I told you, or ways that happens. In this particular example, we have two unconformities or nonconformities. The first one is letter R. Letter R is an extrusive or intrusive rock. An intrusive rock is a rock that kind of intrudes in something else. It kind of runs through it and messes it all up. So in this particular situation, or in most situations, it must be igneous. It must have been liquid hot magma that was powerful enough to get kind of pushed up through here, melting everything in its path. So this R shape, this R rock layer, would have been magma at one point in time in order for it to cut through. The other unconformity we have is right here where it says erosion A. Erosion A is just when we don't have solidly flat layers, and we can tell that there's this particular layer was probably at the surface, at the earth surface for a while and exposed to weathering and erosion. It kind of creates this little like bumpy look, because the surface of the earth is just quite frankly not flat at all, and anything that is exposed to the elements are prone to weathering and erosion. So in this particular situation, anytime you have an intrusive rock, the things that it cuts through must have been there first. So I can still look at P and say, okay, well, P was kind of cut through by R, so P must have already existed before R came along. And P was here before everything else on this list, so P must be the oldest. The same process, I can look at K. K was kind of invaded by letter R, and K was here before everything else, so K must be the next oldest layer. Following that same pattern, kind of working my way up, I also see that M and S must have been here. Hope you're following along. And then finally looking at this X layer, or this erosion A. This X layer was cut through a little bit by R. So in order for it to have been cut through, it must have existed already. So we're going to say X is next. Now R would have come through and up to the surface, but then it doesn't keep going. So was R here before B, or was it here after B? If it was here after B, you would have expected it to kind of cut through, and it doesn't. So R must have been in existence before the letter B layer was put down. But A seems to have happened after letter R, because letter R has a wiggly line up here. That means it must have been exposed to the surface and eroded away. So R would be next. Then we have erosion A, that event that caused a disruption, would have been next. And then the last three are pretty easy. B, J, F. So looking at that, that's the kind of the order. The youngest thing on this would be F. The oldest thing would be P. And you can answer other questions about it, like how many rock layers did R travel through in this diagram or whatever. And you would say P, K, M, S, X. That must have been 5. Let's move on to the next one and see if I can probably try to do a better job explaining. This next one has a lot of unconformities. It has some pretty unusual things. The first thing I notice is that I have slanty lines. Typically in nature, rocks are not, or sediment is not deposited at an angle. Gravity would take over and everything would kind of fall down. So when we're talking about sedimentary rocks, we're talking about things like silt and mud and sand and small rocks. Those things aren't going to stay on an incline forever. They're small, lightweight things that would get moved around. So it's probably a good assumption that there was something that caused these layers to shift. They were flat, and then something caused it to break or shift. So I'm guessing that this was probably at a fault line. So you find the bottommost side, and in this particular case, I'm starting at this corner and kind of working my way diagonally up. So this layer D is obviously the oldest. That's where I'm going to start. I have a few unconformities in this guy too. This big blob right here in the corner is B. Because it cuts through a few different layers, I'm going to assume pretty clearly that that must have been an intrusive rock too. It must have been some sort of magma that got pushed up to the surface and invaded the space of that rock or melted everything kind of in its path. Remember, we're talking about magma. It's crazy hot. So working our way up, it looks like I have all of these things that happen before B does. So I have J, I, A, and G. J, I, A, and G. Before event B. I know that event B must have happened before E because E goes flat across. So B would be next. Now I have another intrusive rock, this little vein right here, F. F cuts through even more. It cuts through even higher than before, than B did. And so F must have been here after everything underneath it. D, J, I, A, G, B, because it cut through B even. It also cuts through E and C, but not H. So I know that E must have been here before F, and C must have been here before F. But H was not. You see that AF does not cut into H at all. So because it doesn't cut into H at all, I'm going to assume that F was here first. And then H was deposited after. One more. I want you to see if you can do it on your own. The guest teacher can pause the video. This one has a lot less layers, so I'm confident that you can do it. So I will pause for just a second, kind of cover up my work, and then I'll put it back up on the screen. So pause the video, and when you feel like everyone in the class is done, you can come back and see what I had said. All right, here is my answer. The most obvious thing on this particular picture is letter B. Letter B is an intrusive rock. It must have been liquid hot magma that cut through any layer it's part of. Because it cut through, the layers it cuts through must have been there first. So E was there, and it's at the bottom, so it's the youngest. C must have been there, and it's right above E, so it's the next youngest. And even part of D was cut through. You can see right here, D was cut through, so D was even younger. D was even there before B was. I'm losing my words. Then we have this event that caused the intrusive rock to come up. And then finally, A at the very top. Give yourself a pat on the back if you got them all right. All right, we're going to flip the page a little bit. Some of these things are probably numbered out of order, but that's not really a big deal. All right, so the next thing we're going to talk about is introducing fossils into these rock layers. There are these things called index fossils. I'm going to write that up here for you. Index fossils. You're probably making fun of my video, but that's okay because I don't care. All right, index fossils are just fossils that can be used to kind of date these things. We've been talking in our stations about relative dating and absolute dating. And relative dating is just when you're kind of comparing these things. So the law of superposition is the easiest way to compare rocks and give them a relative date. This one is older than that one is older than this one is the youngest. Those sort of statements can be made by relative dating. And the law of superposition. So the same thing is true here. But in this case, we now have fossils in these rock layers. You see all these little organisms, all these fossilized animals. And there's two sites. So there's location 1 and location 2. And the rock layers and the fossils can be used to link them together. Now, there were some organisms that lived through many periods of time and in many different types of environment, and those things that kind of appear a whole bunch in the fossil record aren't super useful. It's the things that are very selective that only occur every so often that you can really use to match up. So I'm going to kind of look through these and see if we can match up any of these layers. If we can match them up, then that means they must have had the same fossils in the same type of rock at the same sort of time, and kind of see if we can compare these two pieces of information. So first it says, which fossils exist in layer F? Well, I'm going to look at layer F right here, and I'm going to see what kind of things they have. They gave you a pretty cool key. So this little footprint thing is a dinosaur footprint. So there are dino tracks. That's an A. I don't know why I wrote an A. Dino tracks. I also have this leaf, which they just call plant here. And I also have this feather. That's for a bird. Wow, my letters. All right, so I have dino tracks, plants, and birds in this particular layer of fossils. It says, how did the environment change over time as you go back in time from site 1? So site 1, we have, what is this guy? A mammal, a plant, and a feather. Then dino, plant, feather, no fossils here. Then we have dino and plant, no fossils here. Then we have a shell, an ammonite, which is like a little sea creature that lives in these spiral-shaped shells. We have a fish. Have you noticed some change yet? I have. We have this horseshoe crab-like thing called a trilobite. I don't know if you've ever seen a horseshoe crab, but they live in shallow seas. And then we have another one of these ammonites, which are kind of ocean creatures. So we start with mammals, plants, and birds, and we end up with trilobites, seashells, and fish. So hopefully by now you've realized that we started with a water-based climate and moved to dry land. Mammals live on dry land. I cannot breathe underwater, and I am a mammal. All right, and it says which layers contain fossils that indicate there was once a layer, water. There was once water. Well, any of them that live in water. So trilobites did. So letter A. Seashells and fish obviously do. So letter B. From site 2, we have seashells and fish here. So letter W. And then which layer is the youngest in site 1 and the youngest in site 2? For site 1, the youngest layer is always at the top, just like in any layer or any set of rock. The youngest is always at the top. And in site 2, it must be letter Z. Letter Z is at the top. Okay, and then finally, we have the 5th question. Where layers A and W that should be were, not where. Were layers A and W made at the same time? Why or why not? So I'm going to give you time to answer this one on your own and see what you kind of think. We're looking at layers A and layers W. Do you think they could have occurred at the same time? Why or why not? Everybody's answering. If we're looking at the fossils, we have a trilobite and an ammonite in layer A. And then in layer W, we have a seashell, an ammonite, and a fish. Looking at these and the type of rock and the color of the rock and the type of fossil, I'm more inclined to say that letter W was about the same time as letter B. They have all the exact same fossils, all the same type of rock. So I'm more inclined to say that they're connected in this manner and not so much W to A. So even though site 1 has a layer that's a little bit older, that doesn't change the dates of these things, because if I'm comparing the fossils, these are the two that line up the best. And we just used index fossils to prove our case. It wouldn't make sense for two different sites to have the same exact fossils at two different times. Hope that you're done with this. I'm going to flip the page. I'm going to do a few more questions on fossils, and then I'm going to let you guys do some things on your own. And then we'll come back to absolute dating. All right. So in this particular example, it says, which of the following fossils, fossil A, fossil B, or fossil C, is the oldest, and how do you know? I hope everybody's thinking of their answer. The law of superposition tells us that the oldest layers are at the bottom and the youngest layers are at the top. So if that's true, this layer is the oldest. Therefore, this fossil, the trilobite, is the oldest. And then if you wanted to see the order of the layers, it just goes oldest to youngest. So C is oldest, B is in the middle, and A is at the top. It's the youngest. And then it says, which relative dating technique did you use to figure out the order of the layers? And you just simply used the order, the law of superposition. The law of superposition says the oldest is on the bottom, the youngest is at the top. It doesn't make sense any other way. You don't like layer things upside down, or it doesn't make sense. So oldest is at the bottom, youngest is at the top. See if you can answer these next few questions on your own real quick. I'll show you the answers to them, and then I want you to try the back. There's a whole bunch of questions on the back. 6, 7, 8, 9. And I want to see, this is kind of critical thinking. I want to see if you can make those connections on your own. So I'm going to pause this video again. In just a second, I will show you the answers to 3, 4, and 5 so you can check your understanding. And then you're going to do the back side all by yourself. Okay, I don't know if you can see all of these. Hopefully you can. I'll just get it up a little bit higher. All right, so the first question says, which two layers are approximately the same age? And I gave you two tools in which to do this. The first one is just using the law of superposition to kind of look and see which rocks are older or younger, and you can connect rocks that are similar in composition. If they're similar in composition, they were probably deposited from the same type of environment, which would imply the same time. So I can also look at for index fossils. Index fossils are just fossils that are found in rock layers that can help you connect. In this case, I can see that C and D have both the same type of rock and the same fossil, so they must be the same age or relatively close to the same age. If that's true, just kind of imagine these shifted. So A goes up and F comes down so that C and D are together. And then you would know that F is the oldest because it's at the bottom most, and then A is the youngest because it's at the top. All right, finally, it's your time to practice. This is kind of a critical thinking application of what we've been talking about. You have a few questions to kind of answer. Imagine this is rock that's kind of laid out very similarly to the Grand Canyon. I don't know if you know what happened to the Grand Canyon to make it. But it took a very long time to get there and a very long time to put the rock there in the first place. So you see all these different layers of stone. You can see how long they've been there or about how long they've been there. And then we got this little guy down here, and we're going to try to see if we can figure out what the age of each layer of that is, and sort of if you can use these things. Now, question 7 we haven't talked about yet. It's half-life. And that'll be either a video that you watch right after this if there is time, or it'll be a lesson that we do together as soon as I come back or on Tuesday. But we're going to look at half-life and see if we can kind of make that make sense. So before you guys go to finish this on your own, I have a few things I want to mention to you. First of all, we are planned to have an assessment based on the content of your stations and this that we've talked about today. On Wednesday, you're set to have an assessment. For this assessment, you should know your targets from snapshot 2, which should be in your notebook. I printed those out and gave them to you at the start of the stations, or I think maybe the second day of stations or third day of stations. But they are pretty simple. The targets say, I'm learning to know the age of the earth, so you need to know how old the earth is. You are learning how to age rocks based on rock strata. That's the law of superposition. You can find radioactive decay and find the absolute age of rocks, which we'll work on tomorrow. And then the other things are like vocab that's in your notebook and that sort of thing. So I need you guys to make sure that you're kind of reviewing all of that information. You can check your grade on Infinite Campus and see how your stations did. You can check and see, hopefully I'll have this updated by the time you see this video, but you can check and see your UV bead experiment score. That is always something you can redo if you're not happy with your grade. You'll have a score sheet that tells you how many points you got taken off for which things, so you can go back and fix it. Most people are missing points because they didn't at all talk about their variables, and those were words worth knowing that I expected you to have and to learn. So you need to make sure that you have talked about those, but you can check your grades. Whatever you see that you don't like, you can fix, and you can show me when I'm back, probably on Tuesday. So I'm going to stop talking to you now. I'm sure you're super excited. You're going to see if you can kind of figure out and make some sense of this, figure out where this piece must have come from. And then if you have extra practice time, you can, maybe ask some friends some questions about things that you've noticed in here. I hope you guys all have a wonderful Monday. It's my birthday today, even though I'm not here. Just don't forget tomorrow, and you can shout it at me if you want. I hope you guys have a great day. I'll see you later.